share my screen. Okay, so we were discussing different diode circuits. So last class we have discussed circuits with a resistance and a diode and some bias, right? So we have discussed this circuit. So I also told you to reverse the bias and see what is the result, right? There are four possibilities here, right? We have discussed, right? This is V input. So this is V input, which is we are assuming a sine wave, right? We input as a sine wave and we are measuring output across these 2 points, right? These 2 points. Okay, so one thing, I can reverse the voltage VB. This is VB, V bias voltage. I can reverse the VB and reverse the diode also. Okay, so there are four possibilities like that. I think you have analyzed those things in your notebook. Okay, and we also drawn the V out versus V in graph, I out versus V in graph. Okay, and now we will just take the diode and exchange this part of the circuit with the resistor. Now we'll shift or swap these two things and see what is the output. Okay, so now our circuit becomes, let's say I have taken the resistance from that place and kept the diode in this position, and we already discussed what happens if this is my circuit. There's only one diode in the forward path, and we input we have discussed. If sine wave is going, we have seen what is output. Here the diode is forward bias and the positive bias, so I'll get a positive waveform. Negative waveform will be clipped, so this will be my output, right? Okay, and this also is seen if I reverse the diode also, right? Now if I give a bias to this diode, now we have a diode here. So what if I give a small bias to this diode? That means I have a diode, right? So suppose I give a small bias to this diode. Okay, so now V bias, V plus or minus V2, for example, this is 2 volt. Okay, and I have input, which is, you can say, some voltage like plus or minus 5 volt. Maximum is plus 5, minimum is minus 5 volt. Right, now we are told to find the output, V out. Okay, so I had done nothing, I just exchanged the diode and a bias voltage with the resistance. Now I'm trying to find the waveform, right? Not only the waveform, we have to find the characteristics, V out versus V in, I out versus V in, etc. Okay. So how to analyze this? As we already has done some analysis before, we'll start with asking the questions. What is the state of my diode? Is the diode forward or reverse bias? Yes, there's a bias here, right? There's a battery with 2 volt. So, and which is reverse biasing my diode, right? So diode in natural state without any input, for example, without any input means we are just considering the input is 0 voltage. That means short. For example, this is my input, no input. Without any input, what is status of my diode? Diode is reverse bias. Why? Because my end region is forward bias, or battery voltage plus 2 volt is going across or connected to my uh, n type of my diode, right? P type obviously then will be plus, because this is, sorry, n type is connected to plus and p type is connected to minus, right? So definitely the diode is reverse bias. Okay, so now next question is, um, how much is my diode reverse bias? So you can see that here the diode is reverse bias by 2 volt, right? Diode is reverse bias by 2 volt, right? So that means unless a positive voltage which is greater than 2 volt, that means 2 volt plus, unless a voltage of more than 2 volt is connected or given across the anode, the diode will remain off, right? Unless a voltage greater than 2 volt is connected or uh, given across the anode point, the diode will remain off, right? Okay, fine. So with this thing, we can understand that there are two conditions: diode can be on, diode can be off. Diode can be on if my anode voltage or the input Vi is greater than 2 volt, right? And in all other conditions where my input is less than 2 volt, positive 2 volt, my diode will remain off, right? So there are two conditions. So like last class, we'll write the two conditions. First condition is when input voltage is greater than 2 volt, right? So what is the status of diode? Diode status is diode is on or forward bias. Diode is forward bias. So what will be the circuit? So the circuit will be like this, right? So the input voltage will be greater than 2 volt. For example, here I'm just saying Vi greater than 2 volt, plus 2 volt. That means this is plus here, minus is greater than 2 volt. So diode is on, right? When diode is on, this ideal diode, we are considering ideal diode currently, right? Diode is on. Okay, so what will be my output? Input is greater than 2 volt, that is Vi, and we have 2 volt Vb is also there, and output V1. So let's write the Kirchhoff law, right? So what does Kirchhoff law say? In a closed path, the input voltage drop input applied across the uh, across within the loop is equal to drop across its, right, elements, different elements. So let's write the KVL across the different elements here. Okay, so Vi, Vi is plus and minus. Okay, plus and minus because this is greater than 2 volt, right? Now let's start from the this point, red point here, or let's start from the V input point here. Let's start from here. Okay, bottom you can see the violet color, right? So minus plus, when I'm assuming that increase in potential, I'll write as a plus. Minus plus plus. Okay, plus how much? Vi. We know Vi is greater than 2 volt here, right? Then we are encountering of V bias plus and minus. So it is a decrease in potential. So I'll write minus 2 volt VB minus 2. Okay. Then VO I should assume a convention less plus minus, right? Plus minus. So again VO, again plus and minus minus VO equal to, going to Kirchhoff voltage law, net voltage is equal to 0. Developed or lost across a closed path is 0. So I have to write 0. Right? Now what is V out from this equation? VO equal to VI minus 2. Okay? So VI equal to VO equal to VI minus 2. Now what is the meaning of this thing which we have just derived? That means VO is VI. VI we know is a sine wave, right? V input is greater than 2 volt, it's still a sine wave. But in that sine wave is decreased by a 2 DC voltage, 2 volt. So we'll get V output. Sorry. Okay, so we got a waveform which is waveform or a wave which is subtracted by 2 voltage DC, right? So we'll write here in first condition my output is Vi minus 2 volt, right? Okay, now so how it look like, let's see how it look like. For example, this is my input. So we are talking about the condition when my input voltage is greater than 2 volts. So see, if this is 2 volt, this is 2 volt, what happens? This, we are talking about this area like this. Okay, so my output will be this voltage minus 2 volt. That means my output will be something like this. At this point, my output will be starting. Right now, I'm drawing the output. This will be my output, something like this. Okay, because this is the portion where my output equal to input minus 2. So this will be my green, shown in green. This is V out. This is V out. That is input minus 2 volt, right? So when at 2, input is at 2 volt, my output will be 0, right? That is this point. When input is at 2 volt, my output is at this 0 point, right? And is it going on increasing? My output is going on increasing, but the difference is always there. How much difference? Difference is always there. 2 volt difference is always there. Again, when the input comes back to 2 volt, the output again goes back to 0 volt, right? This is my V input minus 2 volt, right? This is time. Okay, so I got that. Now what is second condition? Now second state is my input less than 2 volt. You know, when the input is less than 2 volt, my diode is off. Okay, so diode is reverse bias or it is off. Now let's see the circuit of the same. So the diode is cut off here. Okay, so this is okay. So I have my diode V in is less than 2 volt, less than 2 volt. Okay, so my output. Okay, so diode is cut, so there is no supply going to the output, right? So what will be voltage? There will be no voltage across the output, right? Because this battery is also disconnected, this battery is also disconnected, right? So that will not be coming in the effect in the output also. So my output will be zero. Again, you cannot apply Kirchhoff law here. Even if you apply Kirchhoff law, we can see there is no closed path here, right? Because it is connected path. So there is no Kirchhoff law, and definitely what is the current through the resistance? That is also zero. So voltage is nothing but zero, right? Therefore V output equal to zero. Here V output equal to V minus. Okay. So this is the case. Now we'll draw it a bit nicely so that now let's see within the same circuit. Can you tell me what is the current waveform? Because we have drawn the voltage waveform on the right, V output and V input. Now what about the current waveform? So here only the current, we can say when the input is greater than 2 volt, the diode is on, although it's forward biased, then only there will be a output voltage. We can see that is only time where there is some conduction happening because the closed loop is happening there only. So we know only at that time when input is greater than 2 volt, my current diode is on or forward bias. At that time only I will have a current. Right? What will be current? You know, current is nothing but I equal to V by R. Right? So this point only I will have a current. Right? I will have a current. And the bottom point where V input is less than 2 volt, diode is off or reverse bias, there will not be current or current will be zero. Right? Because the diode is cut off or reverse biased. Okay, so we can say the current waveform. If someone asks me to draw the current waveform, I know that current waveform just follows the voltage wave like this yellow thing I'm showing in my bottom of my voltage graph. This is my current graph, exactly following the voltage graph. Okay, so let's right now yeah, let's right now draw the plots. Okay, so we already have this is my input voltage. Okay, so how I draw my output voltage? So first I mark the places where 2 volt, right, gain, and this is places, and I have need to draw the current waveform also. So this is V input, I'm drawing V output here. This all with respect to time. I'm drawing I output here with respect to time. Okay, so now I just plot it down over the place where the 2 voltage is happening. Okay, let me also note those points where my waveform is changing the axis, right? These are the areas. Fine. Okay, now I know there will be output when the V input is greater than 2 volt. This is 2 volt plus 2 volt. Okay, so at that point my output is going to start from here and end in here. And what is the output value? Just Vi minus 2 volt. So that's it. Okay, so this is my voltage output value. Now what is the current output value? Exactly, we can just need to extend this thing. Okay, so let me draw the current also here. Current will be exactly this, following the voltage waveform. Why? Because there's only resistance in the circuit, right? So because of the resistance in the circuit, what will be value of my current? You know, current value is nothing but V input minus bias. V bias is 2 volt. V bias divided by resistance. So this is the value of my current. Okay, So current is equal to V input minus V bias divided by 2. V bias 2 volt here. Okay. So now let's draw the plots, voltage versus current plots. Okay. So let's draw first voltage output versus voltage input. Voltage output versus voltage input graph. Right? We know input voltage is varying from plus 5 and minus 5. Right? This varying from plus 5. For example, this is plus 5. From here to here minus 5. Now we can say the output is only shown in the input when the input voltage is more than plus 2 volt. Right? In all other places, the output is 0. So my graph will be like this. Till 2 volt, my graph will be 0. Right? Okay. Till 2 volt, my graph will be 0. After 2 volt, what happens? Output is going to follow my input. Right? Shape wise, output is going to follow my input. That is, then input is going to follow me from here after 2 volt. Okay. Right. So what is this? What is this voltage? This is nothing but 3 voltage. Right? Because 5 minus 2 is maximum possible is 5 minus 2 3 volt. Okay. So this is my V output versus V in graph. And we don't have any negative V output. All the things positive. Okay, fine. So these type of circuits are used to limit the voltage waveforms. Limit the voltage waveforms to less than uh, or we are just trying to reduce some portion of the waveform beyond the limit. Here 2 volt is reduced using the V bias 2 volt. We are reducing the voltage. Okay. Now what is the this is V minus 2 volt. Now what is the current I out versus V in graph? I'm drawing over this only so that right now I'm again drawing I out versus V in. We can see this is nothing but it is also same. We can see it's also follow the same thing. So it will be something like this. Okay, it also follow the same thing. But magnitude wise may be different. So something it will be also following the same thing, something like right. This is something but I also I output. Right? And the value also you should know IO maximum value in the hour or IO is actually the maximum possible is VI minus 2 volt V bias divided by R. Right? Here V bias is 5. Sorry, V bias is 5. V input is 5. Maximum input is 5. The maximum point is 5 minus 2 divided by R. Right? So we can calculate the maximum current and minimum current. Okay, that's it. Okay. Okay, so right now you should be able to do the other. I should be able to draw the diode in the opposite direction as well as the current also in the opposite direction. Not the current, sorry, voltage, bias voltage also in the opposite direction, and you should be able to do the same thing. Right? So you're supposed to, yeah, we have just drawn this diode essentially reverse bias. Okay, so what are the other two possibilities? I can change the direction of the V bias, right? I can interchange the V bias. Okay, this is one, two options are there. Again, diode also I can interchange. So two options are there. So 2 into 2, total 4 possibilities are there, right? So you can try this. There's different possibilities and draw the transient shape of the output waveform. V output versus V in, I output versus I in. Sorry, V in, all those different graphs. Okay, so these are important for exam. But in exam, how I'll give is like something like this. You'll be told to design something like this. Hey, I will say this is a circuit which I don't know what is inside the circuit. My input is a okay AC. My output is something like this. Output is a waveform, something like this. Something like this. Okay. So here input is plus and minus 5 volt. Output is plus 5 volt, but here it is minus 3 volt. Okay, so this is something you have to think what will be the circuit here. So you'll be able to do it if you have practiced the different circuits. Then you will be thinking, okay, I need to cut this point, so I should where should I keep a diode and all those things. Okay, so these things are important, so you have to think. This is the way in the technical quizzes also, technical interviews also, they ask this kind of, design waveform making. It's called waveform design, or you're told to make a shape of a waveform using sine wave. Now sometimes they may ask, let me give a triangular waveform, let me have a square waveform, what will be the output, right? So these are the interesting questions. Square waveform is much easier than sine waveform. Why? Because it is same voltages over the along the, from 0 to t by 2, where t is the, right, it's much easier. Okay, but if you know the sine wave, it's much easier to put other waveforms also without any problem. Okay, so this type of questions you can expect in the technical interviews. Okay, now before leaving the ideal diodes, right now also we are in the state of ideal diodes. So right now there are some important circuits using ideal diodes. We can make some gate circuits. Gates. What are the gates? We already know, or you might have learned already about the different logical gates. What are the different logical gates? Let me draw some gates and you should tell me what are the gates. Say I have a supply voltage plus minus, right? I have some connection like this. One switch is connected like this, and the switch is connected like this, right? And I have a light in the output. So what kind of connection, logical connection is this? This is switch S1, this is switch S2, right? So how am I going to write my output versus input? S1 is one input, S2 is the other input, light is the output, right? So this is my truth table. S1, S2. My input is dependent, output light output here is depending upon the two switches S1 and S2. So I have possibilities. S1 can be off, S2 can be off. Your output light will be, there is no connection. Current always pass to the closed circuit. There is no closed path, so output will be definitely zero, right? What is output? Now if I on one of my input, S2 only, I know the current is complete, the circuit is complete. So according to Kirchhoff law, there should be some voltage on the light. So light is one. Now if I on S1 and off S2, still the path is there. What about 1 and 1? What happens when by switch S1 and S2 both are on? What is my L? Yeah, can type it. Yeah, it's on. Yes, Abhijit, you're right. So it's just same connection, like two switches are parallel connected. Okay, right? So on. Now, if I now this is called which gate? This is called OR gate. Why it is called OR gate? This is called, yeah, OR gate because either S1 or S2 is on. S1 or S2 is on. My output light is on. Light will be blinking. Light will be on, or light is getting output or giving output if either of the S1 or S2 is on. So OR, right? So we can say in one way OR gate is that gate whose output is low if and only if both inputs are low, or both inputs are off, or both inputs are false, right? Okay. Now if I change this thing, if I change this connection, to this switch S1 in series. So this is S1, this is S2. Now how will be the output changes? Now we can see now circuit is complete only if both S1 and S2 are on, because they are in series. Yeah, this is an AND gate. So we can say the truth table will be like this. 0 0, both gates are off, output will be off. If one gate is, or one switch is on, still it is off because circuit is not complete. If both are on, then only output is on. So this is, yeah, this is an AND gate. right? So these are the logical gates. Okay. Now we have one more gate which is called NOT gate, right? This is called NOT gate. If input is 1, output is 0. Input is 0, output is 1, right? This is a negation gate or NOT gate. Okay. We just want to brush up this thing because right now we'll try to uh, make some circuits using diodes. And you should tell me what are the gates. So I have a diode like this. I have another diode like this. Okay. Output of both are connected together. And this is connected to a resistance which is given to the ground. I'm taking output across the resistance. Okay. Now I'm giving a voltage here. Input voltage. This is voltage A. This is voltage B. Now what kind of circuit is this? This diode D1, this is diode D2. Can you just see? Can just see the circuit and tell me what kind of circuit is this? Type in the chat box if you. Okay, so how to analyze the circuit? Just nothing. If we see if V output is high voltage or 5 volt or something. Yeah. So what happens? This is given plus 5 volt. This is high or yes or true, whatever. Right? What happens? This diode is on. Diode is on, there's a current flow. Right? Current flow is happening. The current flow happening, there's a voltage in the output. Okay, or voltage becomes high. So we can see if any of this VA or VB is high voltage or plus 5 voltage, we can see diodes. Any of the diodes is on, any of the single diode is on, your output resistance is carrying a current, and the output is equal to V equal to I into R, right? Voltage equal to current I into resistance. So there's voltage drop, and this voltage across the output will give a high value in the output or a high signal, yes or true. Okay, with true value in the output. That means if VA is high, VB is not high, low, output is high, right? If VA is low, VB is high, output is still high. If both are low, output is low, right? If both input and VA and VB both are off or zero, what happens? If there is no VA, there is no VB, there is no current. Current equal to zero. So there is no voltage across the output. So low, low, low. And both are high, both are on, still there will be current. So output is also high. So this is an OR gate equivalent using diodes, right? Now tell me what is this new circuit. Now I have 5 volt equal to plus 5 volt I give here, and I have a resistance connected to resistance, and I have two diodes like this. Okay, now right now my output is across this part, V output. The output is taken across this point and ground. Okay, now I have two input here also. This is, let's say, VA input is given here. VA and VB. Right, the resistance values are. Now what is this, and how can explain the circuit also? Okay, so first see the diodes. Let's see the diode. Now diode, we should know that diode is anode is on the right side, cathode is on the left side. Anode is here, cathode is left. So diode is forward bias only if my anode is having a higher voltage. But here you can see by default you can see the plus 5 volt. Plus 5 volt is connected to the anode, both anode of this, both diodes. Anode is connected. So by default, this both diodes are forward biased, right? And you can see both the disconnection here. V output, there is no connection to ground. So there is only voltage can go. There is no current cannot pass through this point to the right. Okay, that's the point you noted. And another point you noted is there is a input. VA and VB are the input, right? So based on their values, then only I can tell my diode is forward biased or reverse biased. For example, if I say my VA equal to 0 volt, VA equal to 0, what is the meaning of 0 means reference potential ground. That means I'm giving a ground at the VA. So what is the meaning of that thing? That means now the closed path, now the circuit having closed path. Diode, say I name this diode D1. This diode is D1. This diode is D2. Now I can say when VA is grounded, given a ground or 0 voltage input, you can see now the closed path, the current path is complete, right? This current path is complete. So I can say the diode is on and there will be current flow in this direction. Current flow in this direction, right? And what is the diode resistance? Diode is ideal. Diode is ideal. So this is in the question will be given. Diode, assume diode as ideal. Okay, this is mostly will be told in the question. Okay, so given the diode is ideal, I know there's a current flow and what is the voltage drop across output. Okay, before that we should see what is the voltage at the B also. So V is also given not voltage, 0 voltage, V is also grounded, right? If V is given a high voltage, let's see, let's assume V is given a high voltage. So VB is given a high voltage. That means can say high voltage. That means plus 5 or something, plus 5 or more, whatever. We can say the cathode of the diode 2 is having a high voltage. That means anode is already having a high voltage plus 5 or something. The cathode is also having the same voltage. So there is no biasing. There's no, it is not forward bias. So it will not conducting. So this it acts as a open circuit. So there is no current flow there. But VA is on. There is a complete path from the plus 5 voltage to the ground. This input is 0, like VA is 0, right? So there is a current flow from the voltage source and input VA, right? So what will be output? Now V output definitely will be 0, right? Because there is no voltage drop between VO and ground, right? You can see here, right? Between VO and ground, there is no voltage path. This is connected. Now you can see there is no voltage drop because diode is on, right? So all the voltages drop across the diode and VO equal to 0 volt. Okay. Now, so what is the condition we have here? The condition we have here is VA is VA, VB, and VO. So here VA is 0 or low. VA is 0, VB is high, or we can say high, H. V output is 0, right? In the reverse condition also it's same. If VA is given high, VA is given high voltage, and VB is given low voltage, we can say this will repeat. The same things will repeat also. Why? Because it's same. Diode are symmetrical. Both are looking same. Now the question happens when both are given 0, 0. Both are given low. VA is low and VB is low. So what happens? Same thing happens. We can say even in this case, if VB is also low, what happens? This path is also connected to the ground only. VB, the path towards the current diode 2 is also connected to the ground. Right? Nothing happens. The more current flows from the input voltage source. So nothing happens. Again, the output V output will be 0 only. Now the only case happens, we can see when both VA and VB, when VA and VB both are high and high, high. What happens in this situation? In this situation, we can see that this is the situation, but is both diode is given high voltage, VA and VB are given high voltage. So what happens? Okay, this is VA, This is also given high, VA high voltage, VB. VB is also given high voltage. In this state, you can see that both diodes will be D1 and D2 will be reverse biased or without any bias. So without any bias, there is no current flow through the diode because you can see here high volt means plus 5 volt, plus 5 volt here, plus 5 volt here also. So there is what is potential drop across this diode? Zero, because here also this is 5 volt, right side anode is also 5 volt, cathode is also 5 volt, right? So diode will be in cut-off state. This will be off, this will be off. In this situation, you can see what is the V output voltage. What is V output voltage here? Before understanding output voltage, what is the equation of output voltage V? But this V plus 5 volt is connected, yeah, towards a basing. Yeah, you're right. So the plus 5 volt is connected towards the output, right? So we know if there is a current I, if there is a current I through the plus 5 volt, we know V output equal to according to Kirchhoff law, what is V output equal to plus 5 minus I into R, right? This is the Kirchhoff voltage, right? If there's a current, but here there is no current through this D1 path, D2 path, there is V out path is also, there is no current. Okay, that means current is zero. So what is the meaning of that? Current in zero means this becomes zero. That means V out is nothing but 5 volt. So we have nothing but whatever the supply voltage is coming across my output, 5 volt. Ready? Because there is no drop, there is no voltage drop because current is zero. So whatever the 5 volt applied will be getting across my V output and ground. Okay? Because V out is nothing but the supply voltage VI or 5 volt minus I into R. Nothing but drop across this resistance. But current is zero, there is no drop across those resistance. So whatever input voltage will be coming across my output. Okay, so the last is if VA is high, VB is high, my V output is high, right? So if we convert high to 1 and low to 0 or 0 is low, we can understand that this is nothing but a AND gate. So I'll draw this circuit once again. This is high voltage plus 5. This is a resistance and connected two diodes. Okay, this is VA, this is VB. Now output, I'm connecting across here and ground. Okay, so this is diode D1, this is diode D2. Okay, so this is resistance R. So this is the circuit we are given. So we have known that whenever the diode is on, any of the diode is on, there is a current path. There's a current path to the ground, right? Current path to the ground whenever there is any diode is on. So whenever any diode is on, we know that what is the voltage drop across the V output is zero because this is zero. Any diode is on. So whenever any diode is on, so VA, VB, V output, right? Whenever any diode is on, VA is on, input is on. So when will the diode on? Whenever the input is zero, right? So in this case, first I am owning both diodes, VA 0, VB 0. So I am owning both diodes. The output is 0, right? When I am owning only VA, VB I am giving high voltage. The output is still 0, right? Because there is current flow through the diode D1. Again, I put diode B or diode 2 on by giving a VB a 0 voltage. Now there's current, still the current is passing through diode D2, output is 0. When both of my VA and VB are given high voltage, there is no current through the D1, no current through the D2. My output is high voltage because all the input 5 volt is going to drop across my output because current is 0. So exactly output is 5 volt. And there's no current through D1 and D2. Okay, this will happen when diode is not conducting whenever my input VA is high volt. Right, D1 is not conducting when VA is high, D2 is not conducting when VB is high. Okay, but whenever VA or VB is low, there will be current flow through the diodes and my output will be 0 whenever there's a current flow. Okay, so when there is no current flow, when both VA and VB are high value. So when VA and VB are high value, there is no current flow, my output is high. In all other cases, in any of diode is on, my output is low. So this is called AND gate using diodes. Okay. Okay, so this type of gates uh, will be, so we have one more gate. Sometimes you may be given some question like this. This is plus 5 volt. You can increase the number of diodes. You can have, okay, you can increase number of gates and VA, VB, and VC. You will be asking what is the output here. Okay, so this is also a type of AND gate only, 3-input AND gate, right? The output is high if and only if all this input are high. If this is high, this is high, this is high, my output is high, right? In any of the diode is on, my output has become low. Okay, so I think you don't have any doubts in this thing because this is very basic thing. Okay, so now I'll draw one circuit, similar circuit without any difference. This is voltage to plus 5 volt or whatever, right? Plus 5 volt. Okay, so resistance 5 and I output here. So this is A. So what type of gate is this? Now for your simplicity, I can maybe ground here. Yeah, obey. So if this can be one of the questions in competitive exam kind of thing, we have one diode only and one input. Okay, so the logic is same, and you have to. The question is, what gate is this? This is a NOT gate or NAND gate or AND gate, right? What kind of gate is this? Okay, so this gate is nothing but NOT gate. The same concept here, right? Whenever the voltage A is high, diode is on. Diode is on means voltage, now the Vout is 0, right? So this happens only when A input is high. This happens only when VA equal to high, because then only diode, sorry, whenever A is 0, diode is on, right? When A is 0, diode is on, right? Yeah, diode is on. So output is, yeah, output is also 0, right? When A is 0, diode is, voltage output is 0. Now when A is high, when A is high, when A is high, we can, diode is not working. There is no diode at all here. Now A is high, this is become A is high. That means output is, now output is high. So what is the logical condition here? So the logical condition is V input, V output. VA is high, V output is, V input is high, V output is high. VA is low, output is low, right? Is it okay? So what kind of gate is this? Or is there any confusion here? When VA is high, diode is off. When diode is off, Vout is high, right? Diode is off, Vout is high. If diode is on, that means when VA is low, voltage of A is low, my V output is, V out is low, right? So this is my truth table. whatever my input, that is my output. So this is nothing but we call the same. There's no logic state change of logic here. We can say this is called a buffer, right? Kind of buffer, because whatever the input, I'm getting in the output. If this is high, output is high. When this is low, output is low, right? Is it okay, or is there some doubts here? Okay, so let's draw one more circuit for today. Okay, so I'll draw one more circuit. So we have three diodes connected in parallel. Output is across this resistance R. Right? Now this, I'm just trying to draw three kinds of signals here. Okay, this first signal, second signal, third signal. First signal is like this, plus 3 volt. Right? Second signal is like this. Okay, and third signal is like this. Something, I'm just giving some voltage here. This signal is plus 5 volt. This signal is plus 7 volt. Okay, so I'll also like to give the time. This is, say this is 0, starting from 0. This is 1, 2, 3, 4, 5, 6. And this time, this is 0, 1, 2. Okay, let us begin at 2. 1, 2, 3, 4, 5, and 6. At this last signal, it is 0, 1, 2. This, yeah, let me begin 3. And end at 4, 5, 6, like that. Okay, so what will be my output? So I have given you all the magnitude also. I'm asking you to find the output. And this is also the graph is with respect to time. That's very important to remember. This is time. With respect to time, my signal I am giving. Right? So the first is a rectangular pulse starting at time unit 1, ending at time unit 5 with magnitude plus 3. Second is a semicircular pulse with 2 starting at 2 units, ending at 4 units with maximum voltage 5, magnitude 5. Last is a triangular pulse starting at 3, ending at 4. Okay, starting at 3, ending at 4 here with maximum voltage plus 7 volt. So what will be the shape of my output, V output? Now again in this question I have three diodes. This is D1, you can say D2 and D3. No, question is what is my output voltage? Okay, you can say these are diodes. In the question will be specified that consider diode as ideal or non-ideal. So you have to read that. If it is diode is ideal, we know all these waveforms are in positive direction, right? We know all these waveforms are in positive. This is plus 3, plus 5, and plus 7. So all this diode will be forward bias. All this diode will be forward bias when these waveforms are passed through them, right? And whenever there's a waveform, there's a current will be allowed to pass through the resistance. There's a voltage drop across the resistance. We can see the waveform shape. So we can say all these waveforms are somehow other will be added upon in the output. Both diodes are on, right? So we have a graph like this, starting from you can say 1, 2, 3 or something. 0, 1, 2, 3, 4, 5, 6, 7. Okay, so at one time, at time equal to one, say from here, so at t equal to one, I know the waveform, of what starts? Waveform triangular pulse starts. So I'll draw the triangular pulse here. From 1 to 5, I think. 1 to 5, it is there. 1 to 5, the triangular pulse is there. The voltage is 3 plus 3. Now at 2 to 4, my semicircular pulse is there. 2 to 4, that means 2 to 4, I have semicircular pulse. This voltage is plus 5, right? And from 3 to 4, I have triangular pulse. So 3 to 4, I have triangular pulse. So I'll be drawing like this, something like this. Okay, whose voltage is nothing but plus 7 volt, plus 7 volt. So the wave, the output shape of my output waveform is nothing but all the waves come, all this combined. So I can tell that the shape of my output waveform will be like this. I just share all those things. Okay, so this is will be my shape of my output waveform. Okay, because there's nothing here to think, because all diodes are ideal and they will be allowed to pass the output or the waveform to output. So this is my shape of my output waveform drawn in red color, something like this. Okay, so fine, I think we'll stop it here. Fine, you can put your roll number. So next class we will try to complete the diode thing and we'll start with